Hi friends, welcome back to CADable. This is Engineer Ibrahim Umar, and today we'll be creating this radiator lid in SolidWorks, and you can see that it is a combination of weldments and sheet metal. And the commands we are using in this tutorial are base flange and weldments, hem and fill pattern, etc. So let's start. Let's go to here SolidWorks, new, select part and click OK. I will be sharing its link in the description, and you can download it from the description link. First of all, I'll change my background to plain white, and I'll choose front plane, select sketch, and first of all I will be sketching the basic sketch for tubes. So first of all, I'll go to here corner rectangle, and I'll make one corner rectangle here, and I'll give this dimension as 500 millimeters, and this dimension will be 800 millimeters. Also, I need one tube here and a couple of tubes here, one tube here and one tube here, and the distance from here to here, it would be 300 millimeters, and the distance from, let's say, here to here is 500 divided by 3, and similarly the distance from here to here is also 500 divided by 3. So you can see that sketch is constrained, its sketch is fully defined, the color of the sketch is turned into black, and you can see here as well sketch is fully defined. So I'll exit this sketch, and I'll go to here weldments, and I'll select this structural member, and the tubes I will be using will be square tubes 20 by 20, and you can choose from here angle iron, C-channel, pipe or rectangular tube. I will be using square tube, and the size will be 20 by 20. Okay, and I'll go to here groups, and for the first group I will choose this one, this one, this one and this one, and select this new group, and this time I will be choosing this sketch, this line, these two as separate group. So after creating the tubes, now I will be sketching the sheet, base flange, and select this face, and now I'll go to here corner rectangle, and I'll make one corner rectangle here to here. The dimensions from this line to this center line, it would be 50 millimeters. The dimension from this line to this line would be 100 millimeters, and similarly the dimension from here to here is 50, and the dimension from this line to this center line, it would also be 50. So this would be 100 and all the other would be 50. Exit the sketch, and I need 2 millimeters thickness. K factor is as it is 0.5, and click OK. Now you can see that it is interfering, which we don't want. So I'll go to here base flange again, edit feature, and click this reverse direction and click OK. Now you can see that it is working. So after creating the sheet metal, now we need a cutout here so that heat transfer would take place. So select sketch, and select this face, and I will select corner rectangle again. We'll make a corner rectangle here, and let's change this to, let's say, hidden lines visible, and let's say the dimension from here to here is 50, and dimension from this line to this line is also 50, and the dimension from here to here is 50 again, and the dimension from here to here is also 50. Now you can see that sketch is fully defined. Now I'll go to here fillet, and I will make one fillet of let's say 75 millimeter, and one fillet 75 millimeter, and click OK. Similarly, I'll go to here sketch fillet again, and this time I will be creating a fillet of radius 150, and similarly here, and click OK. Exit this sketch, and I'll go to here Sheetmetal, Extruded Cut, and link to thickness, and click OK. So you can see that this portion is cut out. So after creating the cutout, now we need another sheet, and that sheet would be welded here, and we need a perforation of hexagonal shape. So let's create it. Let's go to a sketch again, select a sketch, and this time I will be sketching on this face, and now I will use offset entities. Okay, so click here, okay, and now you can see the offset of the same sketch. So I will go to a sheet metal base flange, and we need a base flange of 2 millimeters, and click OK. Sorry, let's go to here again, and I will reverse this direction and click OK. And now you can see that a 2 millimeter sheet is pasted here, and now we will create perforations on this sheet, on this newly created sheet. So let's go to here again and go to your sketch. And this time I will be sketching on this newly created sheet, and I'll go to here polygon, and I will create a hexagon here, and this will be horizontal, and the dimension of this inner circle would be 20 millimeters, and the dimension from let's say this line to this center, it would be 85 millimeters, and the dimension from here to here, it would be let's say 95. Okay, now you can see that sketch is fully defined, and I'll go to your sheet metal, extruded cut, and link to thickness, and click OK. So let's go to your features, and this time I will be using a pattern, and this pattern would be fill pattern, and let's say fill boundary would be this one. Sorry, fill boundary would be this one, and the pattern to fill would be this extruded cut, and I need a perforation layout, so I'll change this to perforation, and I need a stagger angle to be changed to 30 degree, and also the instance spacing between these hexagons would be 20. I think I will change it to 22. Okay, now it will work, and click OK. So basically these perforations will help us during ventilation, and this sheet would be pasted, or this sheet would be welded onto this sheet, and I will hide this sketch, and now you can see your radiator lid. we can create a lock here. So I will be extruding, I will be cut extruding a circle here. This time I will be sketching on this face, and I will be creating a circle here, and the diameter would be, let's say, 30, and let's unhide this sketch, and the dimension from, let's say, here to here, it would be 50, and the dimension from here to here is also 50. I have already calculated these, and now you can see that sketch is fully defined. You can see here as well. Sorry, this is 50, not 5. Okay, now you can see that sketch is fully defined. I'll go to here, Sheetmetal, Extruded Cut, link to thickness, and click OK. So this will be the hole for the lock, and you can create one lock here, and you can assemble it. So after creating this, lastly I will apply hem onto the edges of the first sheet. Let's go to here, hem, and I will be creating a hem on these 4 edges. So let's change this length to 10 mm, and select this edge, select this edge, select this edge, and select this edge. I will change this gap to 10 mm as well, and now you can see preview of the hem. Let's change this to closed hem. Okay, now you can see preview of hem. Okay, so lastly I will apply appearance onto the tubes and sheet. So first of all I will apply blue anodized aluminum to all parts, and now I will apply a different appearance to the tubes. So let's go to here, steel, and this time I will select this square tubes, all square tubes, and I will apply satin finish appearance to the tubes. Now you can see that satin finish appearance is applied to the tubes, and also this second sheet, and let's select this tab, and let's go to here, let's say copper, and let's go to here brass, and select this polished brass. So now you can see that polished brass appearance is applied to the second sheet, which would be pasted or welded here. So that's it for today's tutorial. I hope you like it, and if you have any questions, any queries related to this tutorial or any other tutorial in my list, you can ask in comment section. Thanks for watching, and please subscribe to our channel for more informative and interesting videos. Thank you.